Assalamu alaikum. So in this video we will try to learn how to find the solution of this equation. That means we will find the value of y, but before solving this equation we have to know some theory. So let's dive into the theory. So it's the general equation of the previous equation, so don't be afraid. I will try to explain this thing simply. So first look at right hand side. You will have a 0 at the right hand side, and that's why I will call this equation a homogeneous equation. And then you will have a power 1 above y. You have all the y has a power of 1, and that's why I will call this equation a linear equation. If you have y square or y cube terms, or you have xy or x square y terms, you can tell this equation a linear equation, right? Okay, you have a power 1 above y, and that's why you have called this equation a linear equation. And then you have a differential operator here. These are called differential operator, and that's why I will call this equation a differential equation. Okay, so linear, homogeneous, linear, differential equation. And finally these are coefficients a1, a2, and you will see that these equations are constant, right? Let's compare it. You will see that these coefficients are constant, not dependent, not a function of x or y, and that's why I will call this equation with constant coefficients. Okay, now let's learn the procedure how to solve this equation. To write this equation simply, I will write d by dx as capital D and d square by dx square operator as capital D square. And I think you have got the pattern. If you have d to the power n, dx to the power n, you will write d to the power n, right? Okay, so simply this is d to the power n, and then this differential operator can be written as dn minus 1, then a to dn minus 2, and it will go up to here. Okay, now what I will do, I will write y here outside the bracket, and inside the bracket I will write the terms of d like this, and this will go up to a to the power n. Okay, so now what we will do, we have to convert this thing, the terms of d, into like this: d minus, let's say, m1, then d minus, let's say, m2, up to d minus, let's say, mn. If I somehow can convert this equation like this, I can solve the equation. So now let's go to our question, this. So let's solve this equation. So what I will do, I will write this term as d, okay, and then I will write this term as d square, and this is 6y, and then I will write y outside the bracket, and inside the bracket I will write inside the bracket I will write d square minus 5d, then 6. Okay, so you can convert this equation into d minus 2, d minus 3, y is equal to 0. So from this I can write d minus 3 y is equal to 0, and then d minus 2 y is equal to 0. I can write this, or I can write this. So I have two equations from the main equation, and then we will solve these two equations separately. So let's write this term as dy minus 3y, and then take this 3y at the right hand side and write this as d by dx. Okay, now take this y here and take this dx here, and then integrate the both of the side, and you will have a ln y, and at the right hand side you have 3x plus c, and then if you write ln to the right hand side, shift this thing to the right hand side, you will have a exponential. So e to the power 3x plus c, and then e to the power 3x e to the power c. Okay, so now e to the power c, what is this? It's a constant, right? And we can write e to the power c as a new constant, that is c1. So see, we have find a solution. So it's one of the solution, it's one solution. And we will find another solution from this equation. So in this case we will not do the whole process here, but we will try to find the pattern. See, we have a constant here, so from this equation we will have another constant here, and then we will have to write here. Okay, so from where this 3 comes from? This 3 comes from here, right? So you have 2 here, so similarly you can write e to the power 2x. Okay, here 3, so you have 3, then here 2, so you have right here 2. It's another solution of this equation. And now if I want to write the solution of this equation, I can write solution of the equation. Which equation? This equation. I can write, be careful, see what I am writing. I can write the sum of these two solutions, c1 e to the power 3x, then c2 e to the power 2x. And I think you might be wondering why I have do a summation of two solutions here, and I call this summation the solution of the main equation. That means this equation, the solution of this equation is summation of these two solutions. But why? What is the reason? Let's try to find out the reason in this slide, and after this slide you might be wondering how to find c1 and c2. I have another question at the last slide. So how to find c1 and c2? So first let's go to the previous slide. Here, why we take the sum of these two solutions is the solution of the main equation. Why? So let's try to find the answer. I can write this equation as d square y minus 5dy plus 6y is equal to 0. And I have found two solutions here, right? I have found here c1 e to the power 3x, and I have find c2 e to the power 2x. So what is solution? I can write this y here, so I will get d square c1 e to the power 3x, then c1 e to the power 3x plus 6 c1 e to the power 3x. And if I again write this y in this equation, I will have d square c2 e to the power 2x, then c2 e to the power 2x, then 6 c2 e to the power 2x. Okay, now what I have said, that y is equal to the solution of the equation is c1 e to the power 3x and c2 plus c2 e to the power 2x. c1 e to the power 3x, then c2 e to the power 2x. Is it real? Is this the solution? I want to check the solution, that whether this solution is the solution of this equation or not. And what is the procedure? How can I check this thing is the solution of this equation or not? I have to put this y here and see the value of this thing is 0 or not. Let's do this thing. So d square c1 e to the power 3x, then c2 e to the power 2x, then minus 5d c1 e to the power 3x, c2 e to the power 2x, then 6 c1 e to the power 3x plus c2 e to the power 2x. Okay, so write this thing, d square c1 e to the power 3x. It's almost finished, please keep patience. Then minus 5d into this thing is equal to minus 5d c1 e to the power 3x. Then 6 into this thing is 6 c1 e to the power 3x. Okay, now d square, I write it in another. Okay, d square c2 e to the power 2x, d square c2 e to the power 2x, then 5d c2 e to the power 2x, 5d c2 e to the power 2x, then 6 and this. Okay, now see the carefully that what is the value of this term. You will see the value of this term is equal to 0, right? You can see that this is 0 and this is equal to this, so it's 0. Then what is this? It's equal to this, right? So it's also 0, and finally I get 0, and this is the solution of that equation. It's proved. So the moral of the story is you have to find solutions. It might be 2 or 3 or more, and then you have to sum up all the solutions, and that is the solution of this equation. Okay, so we haven't find the value of constant here. We have c1 and c2, and these are called arbitrary constant. So we have to find the value of these constants. So what can we do? We should have to give some data here. You will see that when x is equal to 0, the value of y is 1, and when y is equal to x is equal to 2, y is equal to 4, right? So let's write the equation. Y is equal to c1 e to the power 3x, then c2 e to the power 2x. Okay, so now when x is equal to 0, y is equal to 1. So 1, so the value of y is 1, then c1 e to the power 0 means 1, then e to the power 0 means 1, right? So I can write here c1 plus c2 is equal to 1. And then if x is equal to 2, x is equal to 2, y is equal to 4. So 4 is equal to c1 e to the power 3 into 2, c2 e to the power 2 into 2. So finally I have e to the power 6 c1 plus e to the power 4 c2. Okay, so I have got two equations, and if I solve these two equations by calculator, or however you can solve these two equations, you can find c1 and c2. Okay, so find the value of c1 and c2 and tell me in the comment section. And in the next video we will talk about some more equations. We will see some cases like when two roots are equal, then two roots are of complex number, and many cases. So let's meet in the next video. So thank you.